Now our today's topic is cobweb model. I have tried to type all the theory for you people so that instead of listening to my words and writing them or understanding them, I have written the theoretical part over here because this is the coursework of BS 6th semester. So I don't want to put you people into some trouble. You can use Alpha C. Chang Mathematical Economics books. Book for the reference, and of course you can use the theory from there. I have taken it from there. So what is cobweb model? To study the use of first order difference equations in economic analysis, we use two equations in economic analysis. We use two variants of market model for single commodity. The first one is cobweb model, which we will study now, and I'll explain the second one when we will be studying it. So in this model, the quantity supply is not the function of current prices, but it depends on the prices of the preceding time period. Now the model shows that the producer output decision must be made one period in advance of the actual sale. That is, if I'm a producer, I want to sell my output in this year, then I should make my output decision in the previous time period, that is in the year 2020. Suppose here the example is given of an agricultural production where the planting must proceed by an appreciable length of time in the harvesting, sale, and output. Planting is done a year before or by an appreciable time before, like 6 months before 3 months before, so that the plants grow and they are ready to harvest and then of course to be sold in the market as an output. The output decision in the period T, this is small t, okay? The output decision in the time period T is based on the prevailing price, that is PT, okay? That is price in the current time period T. So therefore, the output decision in the time period T is based, output decision, over here we're talking about the output decision. It is in the time period, in the period T is based on the prevailing price PT. This output will not be available for sale until time period T plus 1. Now here comes the difference. This output will not be available for sale until time period T plus 1. However, PT will not determine QST as told earlier. PT will not determine QST but QST plus 1. PT will determine QST plus 1. Therefore, now we have a lagged supply function, that is QST plus 1, okay, is the function of PT minus 1. This should be clear to you. Prices in the time period T minus 1 will determine the supply of the product in T plus 1. Or equivalently, we can shift back time subscript by one time period, okay? Therefore, QST SPT minus 1, this can be written as, now let me explain it to you again. Either you can write the function like this, the one that has been mentioned over here, or you can write the function like this as well, like this. Let me just, okay, you can write the function like this, or you can write the function like this as well. So therefore, what happens is that now the demand function is as follows. Q dt is equal to D into PT. Now we will take the linear version of the lagged supply and unlagged demand function. The demand function is unlagged because Q dt is equal to dpt, whereas the supply function is a lagged supply function where QST is equal to S into PT minus 1. So therefore, now let's move forward and start solving this particular model in order to understand it. So we'll take the linear version of the lagged supply and unlagged demand function, and we will assume that at each time period on market price is always set at a level which clears the market. As we know that at equilibrium, the price should be such that it clears the market. If it is not such that, then our equilibrium price cannot be attained. We will not be able to find out what kind of output is important to be sold in the market so that it is completely consumed by the consumers. So therefore, this is an important assumption that at each time period, market prices is always such that it clears the market. So therefore, we know from our simple market demand and supply functions that Q dt is equal to QST. Okay. Okay, we know that Q dt is equal. Now we know that Q dt is equal to QST. Okay. Clear? And now we will expand QDT and QST. One thing you have to keep in your minds is that this is not a lagged function. This is a simple function, okay? Whereas QST is a lagged function. So therefore, this clarity should be kept into your mind. QDT is equal to QST. Now QDT is equal to, let's expand it, QDT is equal to alpha minus beta pt. I'll be reminding you again and again that it is not a lagged function. Alpha minus beta pt. We can see that the current demand of the function of the product depends on the current prices of the product. Clear? Okay. Now what is QST? We will expand this one as well. QST is equal to, now this is a lagged function of the prices. So therefore, QST is equal to minus C plus D P T minus 1. Okay. dpt minus 1. Now can you see over here? This is the supply function taken from here. This is a lagged function and this is an unlagged function. So now what we do is that we know that at equilibrium Q dt is equal to QST. We will equate both of them with each other. Therefore, Q dt is equal to QST means that, therefore, what we do is that we say that by putting this value and this value into this particular equation, we get alpha minus beta pt, alpha minus beta pt is equal to minus C, or in place of this C, let us take this to be equal to minus gamma, is equal to minus gamma plus, and let this D be sigma, okay? Minus gamma plus sigma P T minus 1, okay? So therefore, what we will do next is that rearrange the equation. That is, we will get alpha plus gamma on one side and the coefficients on the other side. That is beta pt plus sigma pt minus 1 on the other side. Coefficients of the price variable are both brought together. Now what will we do next is that we will divide this whole function by beta, okay? Now divide, let this be, for our simplicity, let us name this as equation number A. Now divide equation number A by beta. So what will happen over here is that alpha plus beta, and we arrange the following equation. We get beta pt plus sigma pt minus 1. Okay. The whole divided by beta is equal to alpha plus gamma divided by beta. So what's the purpose of this? The main purpose of this is to get the value of, to find out or to get the general equation for this particular problem. That is the problem of cobweb model. So when we will divide beta with beta over here, we get only pt. When we divide sigma by beta by with sigma beta raised beta with sigma pt minus 1, we get sigma upon beta into pt minus 1, and this will remain the same, that is alpha plus gamma divided by beta. Therefore, by dividing beta pt by beta, we get pt only over here. That is sigma is cancelled with, beta is cancelled with beta. Over here, what we will get is that we will separate the sigma by beta and multiply it with pt minus 1. And of course, on the other hand side of the equation, we get alpha plus gamma divided by beta. So what next? What next is over here? We have pt plus 1. What we will do over here, that we will add an increment of one time period in this whole equation. That is add an increment of one time period in this equation. Now, by adding an increment of one time period, what we get over here is that we will add, okay, let me just simply write it over here. What we will do, we will add 1 plus 1 over here and then plus 1 over here, because there is no p over here, so therefore we cannot add an increment over here. This plus 1 will be cancelled with minus 1, and over here we will get pt plus 1. Therefore, okay, let me correct this as well. So this will now become pt plus 1, okay, plus sigma upon beta into pt, because one has been cancelled out with the other one, that is a positive one cancelled out with a negative one, is equal to alpha plus gamma upon beta. So this is the equation that we have got, and this is the general form of the equation that we should get in the cobweb model. Now we will solve this equation and we will further find out the general solutions and definite solution for this particular equation. So therefore, pt plus 1 plus sigma upon beta into pt is equal to alpha plus gamma upon beta. What next we will do over here is that pt plus 1 plus sigma upon beta into pt is equal to alpha plus gamma divided by beta. Now we know that this is the constant value or the term which is not equal to 0 when we are studying the non-homogeneous case. So therefore, over here also this is not equal to 0. And in order to study it simply, or for simplicity, what we will do is that we will term it as the value c. And again, this alpha, sigma divided by beta, let this be termed as a. So therefore, by further simplifying this equation, what we get is, we get pt plus 1. Now slowly and gradually, we are converting this into the first order linear difference equation. pt plus 1 plus a pt is equal to c. Now this is what we derived previously as well. In the end, when we get the solution, we will again substitute the values of ca and c in the equation. So therefore, pt plus 1 plus a pt is equal to c. And again, previously, which term we used in order to study the general terms, we used y instead of p. So therefore, again, we will use y over here, yt plus 1 plus apt. And again, I'm recommending you people to study the previous two lectures of the first order difference equations and first order linear difference equations, so that you may understand this whole concept very well. You should write y over here, not p over here. Ayt is equal to c. Now by doing so, what we will do is that now we will get the two types of solutions over here. The first one is the complementary solution, and we know that complementary solution is equal to yc is equal to a into minus a raised to power t. Okay. By this, we mean that we have got the complementary solution, and we always get the complementary solution by putting c is equal to 0. And when we want to find out the particular solution, we will not put this equal to 0. So therefore, yc is equal to a into minus a raised to power t, and yp is equal to, yp is basically equal to c divided by 1 plus a. Okay. Now we know that yt is equal to yc plus yp. So therefore yt is equal to yc plus yp. The value of yc now is equal to this one. So therefore substitute it over here. It will become yt is equal to, so therefore what will we do? We will put the value of yc over here, that is a into minus a raised to power t. And the value of yp is equal to plus c over 1 plus a. And this is the value of yt. Yt is equal to a into minus a raised to power t plus c upon 1 plus a. What next we will do is that we will put the value of t equal to 0. If t is equal to 0, we will get y of 0 is equal to a into minus a raised to power 0 plus c upon a. We know that this minus a raised to power 0 is equal to 1. So therefore, what happens over here is that y of 0 is equal to a plus c upon a. That is a plus c over c upon 1 plus a. Now we can find out the value of this a from this equation. We know that a has now become equal to y naught minus c upon 1 plus a. Y naught minus c over 1 plus a. Okay. So what next we will do is that we will substitute this value of a into our definite solution. And where is the definite solution? This one. Yeah. We will put the value of a over here. That is, so therefore this equation will now become equal to yt is equal to, okay, let me just be a little bit. Okay, now I have zoomed out the screen a bit more. Now yt is equal to a into minus a raised to power t plus c upon a. We know this from this, and after solving this, we got the value of a. Now we will substitute the value of a in this particular equation. So therefore, yt is now equal to y naught. Okay, we will have to make this bracket over here. Y naught minus c divided by 1 plus a. There, multiply by minus a raised to power t plus c upon 1 plus a. So this is what we have got after finding the general solution, and through that we found out the value of a, and then now we have definitized that solution. So therefore now this is the definite solution. This is clear to us till here. So what next we will do over here is, the next step over here is that we will move on towards the substitution of the values of y, c, and a from the and we will put the original values into it. We know that we took this y from pt, so therefore we will write pt over here. Pt is equal to, now instead of y naught we will get, or we will write p naught over here. Now what was the value of c? So this is the value of c. Let me be more close. Yeah, this is the value of c, alpha plus gamma upon beta. So therefore pt is equal to p naught minus alpha plus gamma divided by beta. Okay, and this whole is now divided by 1 plus a. That is 1 plus, over here the value of a is sigma upon beta. So therefore we will write it as sigma divided by beta. The value of c has been taken from here. Okay, let me look. And the value of a has been taken from here. Okay, we have substituted them back, and therefore we got this. Okay, one more thing over here is that this is alpha plus beta, the whole divided by b. So therefore, I need to rewrite it again, because I know students, sometimes they do not get the right point and therefore they solve it correctly. So therefore, this should be alpha plus gamma, the whole divided by beta. Yeah, divide the whole divide, and then divide this by 1 plus sigma by beta. Now the value of A again is sigma by beta. Over here, A is assigned a negative value. So therefore, we write it as minus sigma divided by beta, the whole T. Plus again, the value of C is alpha plus gamma. Again, this value there. So therefore, we get alpha plus gamma, the whole divided by beta. And again, this whole is divided by 1 plus sigma divided by beta. Now, what next will we do over here is that we will find out the LCMs and complete this whole equation properly by solving it. So therefore, PT is equal to P naught minus alpha plus gamma divided by beta, the whole divided by 1 plus sigma upon beta into minus sigma upon beta raised to power T plus alpha plus gamma upon beta, the whole divided by 1 plus sigma upon beta. So therefore, now PT is equal to let me solve it again, P naught, okay, P naught minus, now this should become alpha plus gamma, the whole divided by beta, because this beta is basically multiplied by this equation. So therefore, it will become like this, beta into 1 plus sigma upon beta, I've written it, sigma upon beta, is it here? Then close this bracket, close the other bracket, we will get minus sigma upon beta. Now this calculation needs to be correct at all costs in order to get the correct results. Therefore, I'm doing all the steps over here for you people. Alpha plus gamma. Again, the whole divided by, this is a plus sign. Okay, don't take it to be T, rather this is a plus sign. Alpha plus gamma divided by beta, and this beta is multiplied by 1 plus sigma upon beta. Okay, the whole divided by beta. Now what, okay, this is beta, not P. Okay. Now what next we will do is that, now find out the proper solutions for this. Therefore, now PT is equal to, what is PT equal to? PT is equal to P naught minus alpha plus gamma, where the whole divided by beta. Now when we take the LCM within this bracket, we get beta plus sigma, okay, the whole divided by beta. Now we can very clearly see that this beta can be cancelled with this one, and therefore we get again a minus sigma upon beta over here. Okay, the whole P plus, this is again a plus sign over here. Exactly the same calculation will be done, which over here, the one which was done over here. Therefore, what we get over here is beta into beta plus sigma. Okay, and divided by beta. This beta will be cancelled out with the beta, and therefore, in the end, by solving it, what we get over here is, okay, I want to write this beta correctly. This is minus sigma divided by beta. Okay, so after further simplifying it, removing the cancelled out values, we get PT is equal to, now P naught minus alpha plus gamma divided by beta plus sigma squared into minus sigma upon beta, the whole raised to power t plus alpha plus gamma. Okay. Alpha plus gamma divided by beta plus sigma. Beta plus sigma. Okay, this is plus sign. Okay, this one is also a plus sign. So what do we have as alpha plus gamma upon beta plus sigma? If you remember your main economics, the simplest microeconomics specifically, we know that alpha plus gamma divided by beta plus sigma, that is always equal to P bar. A plus C upon T plus upon B plus T is equal to P bar. The coefficients, when they are written in this form, they represent the equilibrium prices. So therefore, the time path of the prices at time period T is equal to P naught minus P bar. Or let me write it with this particular pen, this orange pen. Let's move to orange pen. PT is equal to P naught, okay, minus P bar into minus sigma upon beta raised to power T plus P bar. Okay, there's one more thing that we have not substituted it yet, is that this sigma upon beta. This was, we have taken this from A. So therefore, PT is equal to P naught minus P bar into sigma upon beta raised to power T plus P bar. Therefore, an important point over here is that P bar is constant, so it shows the stationary equilibrium. We always know that the prices should be such that declares the market. So therefore, this P bar shows the stationary equilibrium. This P bar will not show the equilibrium, that is not stationary. This always shows the stationary equilibrium, okay? P naught minus P bar. What is this P naught minus P bar showing? Okay. P naught minus P bar corresponds to constant A in terms of A, B raised to power T. So therefore, if we rearrange this equation, we can also get it in this form. We know that always that PT is equal to A, okay, B raised to power T. We know this thing very well, okay? So therefore, this P naught minus P bar is now referred to as A, and this B will be referred to as minus sigma upon beta, and T, of course, we have got it from here. So therefore, it can also be written as PT is equal to AB raised to power T. If we are writing it in this form, it means that A is P naught minus P bar and B is minus sigma upon beta. Clear? We can also write it like this. So therefore, P naught minus P bar corresponds to constant A in terms AB raised to power T, and its sign will indicate whether the time path will commence above or below the equilibrium, and its magnitude will decide how far above or below it lies. As in the preceding lecture, I explained you the dynamic equilibrium prices, equilibrium positions, stability of equilibrium. When this value of B determined what kind of time path was the economy following. So therefore, P naught minus P bar will give us the type of whether the time path is convergent, divergent, or uniform. Clear? Then the next is sigma upon beta corresponds to the component which we have studied already. Okay. This sigma upon beta is an important component of AB raised to power T, and it is the B part of this term. So if beta and sigma are greater than 0, if sigma value and beta value is greater than 0, we will deduce an oscillatory time path. And if beta and sigma are greater than 0, it also leads to the cobweb phenomena. So therefore, this B part where we have sigma upon beta, if both sigma and beta are greater than 0. Okay, if sigma is greater than 0 as well as beta is greater than 0, then we will have an oscillatory time path, and when beta and sigma occurs are greater than 0. So therefore, it will lead to a cobweb phenomena. We can have some other possibilities as well. What are those very important possibilities that we should know in order to study the cobweb phenomena? Those possibilities are that if the, I just want to check out something. Yeah, those possibilities are if sigma is greater than beta. Okay, if the value of sigma is greater than beta, then there will be an explosive time path. Now, what kind of time path is explosive? That I have explained to you in the previous lecture. You can find it on YouTube through the dynamic stability of equilibrium heading. If the sigma is equal to beta, then what happens is that we will have uniform time path. Again, the uniform time path diagram can also be seen in my previous lecture of the dynamic stability of equilibrium. And if the sigma is less than beta, then we have damped oscillations. And what are damped oscillations? Again, I would request you to study or to check the lecture with the name of Dynamic Stability of Equilibrium in my YouTube videos. So now let's go and let's move towards our diagrammatic explanation of the three terms, that is sigma greater than beta, sigma is equal to beta, and sigma less than beta. What happens over here is that we will have three different types of diagrams. So we will have three different diagrams. First of all, we will move towards the first diagram, that is the explosive one. That is, let it be 1, let it be 2, and let it be 3, okay? Let me increase its size, okay. Now we will draw the explosive diagram first. In explosive diagram, what happens over here is that again, we have this vertical axis and the horizontal axis, clear? Now we have the demand curve, we have the supply curve. When we are studying the cobweb phenomena, our points of equilibrium are not as simple as they were in the, okay, let me just do one more thing over here. Now when the thing is that when we are taking the Q on vertical axis and P on the horizontal axis, okay? So now cobweb phenomena will be explosive if the given diagram or if the given time path is such that it is moving in this way, that the amplitude of the cycle is increasing with each possible value, okay? That is also increasing. So therefore we can see that from this initial equilibrium position, the time path is deviating away from it, and the amplitude of the trend is increasing. This one is smaller than this one. Again, you can see that the amplitude is increasing with time. So therefore, this is basically the exploding time path. Over here, we can say that sigma is greater than beta. Now on x-axis, we have taken different values of prices P, okay? On y-axis, we have taken different values of Q. On different values of P and Q, what happens over here is that the oscillations are expanding, exploding. Specifically, you should use the word exploding. Then in the next one, that is the second figure, we have, okay, when a sigma is equal to beta, then the oscillation should be such that it is moving in with one particular level of, okay, no, wait, let me just try it again. It should be such that the amplitude of the oscillations is exactly the same. That is, it is not changing or it is not increasing or decreasing. The amplitude is same. Okay. Over here, sigma is equal to, okay, over here, sigma is equal to beta. That is, the amplitude is same at all points. So we have taken on vertical axis Q and on horizontal axis we have taken the P. Now the third one over here is the damped oscillations. What happens in the damped oscillations is that the cycle is moving towards the, it will start from some higher point, okay? And it will move towards the equilibrium point. That is the central point. You can see over here, these are the damped oscillations. I hope you're getting my point. Now these are the damped oscillations. The amplitudes become smaller and smaller, and it is, okay, wait, it is moving towards the equilibrium point as well. There. Okay, so these are the damped oscillations. Therefore, here the value of sigma is less than the value of beta. Again, these on vertical, horizontal axis, we can see that we have different values of P, and on vertical axis, we have different values of Q. The same is the case for figure 2, and the same is the case for figure 3 and 1 as well. Okay, P and P. So therefore, these are the three types of cobweb models and its phenomena. Now we will move towards an example quickly, and we will solve that. And after that, this topic will be completed over here. I would request you to solve the question first by your own self. And then if you do not understand it, then please take the help from the given lectures. Therefore, we will now move towards the numerical example, and we will solve it completely. Now, this is the question that we will solve over here in our lecture today. This question shows that the demand function is 18 minus 3 pt and supply function is minus 3 plus 4t minus pt minus 1. This is an unlagged function. This is a lagged function as according to cobweb model. It should be of the same kind. We will solve this function through the cobweb model phenomena. We know that at equilibrium, q dt is equal to qst. Again, I'm requesting you to solve it yourself first. If you do not understand it, then kindly consult this video. Q dt, okay. Now, and Q dt is equal to QST. So therefore, we will equate these values with each other. That is 18 minus 3 PT is equal to minus 3 plus 4 PT minus 1, okay. Minus 3 plus 4 PT minus 1. Now, what was our next step was to bring the constants on one side and the coefficients on the other side. And that way, what we will get is that we will get 18 plus 3 is equal to minus 3 minus 3 will shift when it is shifted on the right hand side. We get 3 pt plus 4t pt minus 1, okay, plus 4 pt minus 1, okay. Now we can do one more thing over here, is that we can also shift these values on the left hand side. Therefore, 18 plus 3 minus 3 pt, it can also be written as, likewise, it can also be written as 18 plus 3 minus 3 pt minus 4 pt minus 1, okay. Minus 4 pt minus 1 is equal to, now it should be put equal to 0. So now what we get over here is that 18 plus 3 is equal to 21. And this will now become minus 3 pt minus 4 pt minus 1 is equal to 0. Okay. Minus 4 pt minus 1 is equal to 0. So therefore, it means that we have minus 3 pt, okay, minus 3 pt minus 4 pt minus 1 is equal to minus 21. Clear? Now what we do next is we can take the minus sign common. Therefore, it will become 3 pt minus 4. Oh, sorry, we have taken this minus common, so therefore it will become plus 4 pt minus 1. Minus has been taken common for this one only. This cannot be taken as common, is equal to 21. So therefore, our equation can now be written as 3pt plus 4pt minus 1 is equal to 21. Now, as we know that one thing is clear over here, and that is when we got this equation in our derivation, we first we added a time subscript of 1 to the equation, and then we did some division in that derivation. So therefore, we will repeat exactly the same steps. The first step will be, we will add a time subscript to this general form of equation. And by adding a time subscript to this general form of equation, what we will get over here is that we will get this to be 3pt plus 1, and this will become 4pt minus 1 plus 1. This minus 1 and plus 1 will be cancelled out with each other, and our new equation now will be 3pt, okay, plus 3pt plus 1 plus 4pt is equal to 21. Is equal to 21. Now, we know that this 4 is equal to A, 21 is equal to C, okay? 4 is equal to A, 21, this is equal to C, okay. So, and this Y, let's write in the general form, this P in the general form, we write it as Y. So therefore, let us now do it once again. So it will become now 3 YT plus 1 plus A is equal to 4PT, okay? Is equal to C, that is 21. One more step is left over here, is that we have to divide this whole equation by 3 in order to bring 1 over here, because that will give us the first order linear difference equation. So therefore, the general form of first order linear difference equation. So therefore, we will divide this whole equation by 3. This first value is divided by 3, second, and third one is divided by 3. So therefore, we get now YT plus 1, okay, YT plus 1 plus 4 by 3. Okay, one thing left over here is that this should be Y, not P. Okay, yeah. Plus 4 upon 3 plus 4 over 3 YT, and 21 divided by 3 is equal to 7, of course. What next we will do over here is that we will now solve it. We know that YT is equal to, YC plus YP. Clear? YC plus YP. This is C, okay? YC is equal to A into minus A raised to power T, okay? So therefore, and YP is equal to 7, okay? YP is equal to, let me write it over here, C over 1 plus A, okay? So the value of C is equal to 7. We know that this 7 is equal to C, clear? Divided by 1 plus the value of A is equal to 4 by 3. This is equal to A, clear? So 1 plus 4 by 3 will come over here, and therefore YP is equal to 7. Now by taking the LCM in the numerator, we get 3 plus 4 upon 3. So what will we get over here is that yt is equal to 7 divided by 7 divided by 3. 7 and 7 will be cancelled with each other, and therefore what will be left of yt is 1 divided by 1 by 3. The denominator in the denominator is always equal to the numerator. So therefore the value of yt is equal to 3. Okay. Now let's move forward, and we will now definitize our general solution. For that, we need to write our general solution first. So therefore, let's come here. Okay, let me take this red pen. Now yt is equal to the value of yc is equal to a into the value of minus a is equal to now minus 4 by 3. Okay, raised to power t plus the value of yp is equal to 3. Is it clear? What we will do is that this is now named as the general solution. Now what will we do is that we will convert this into a definite solution. Therefore y of 0, that is, we will take the value of t to be equal to 0, a into minus 4 by 3, the whole raised to power 0, which will become equal to 1 plus 3. So therefore y of 0 is equal to a plus 3. If y of 0 is equal to a plus 3, it means that a is equal to y of 0 minus 3. So therefore, a is equal to y of 0 minus 3. Substitute this value of a is equal to y of 0 minus 3 in this particular equation. What will we get is, we will get a definite solution, that is y of t is equal to, in place of, wait, is I have to correct this one, because sometimes this self-correction comes into being and the software converted this 3 into 0. I have to correct it again. So therefore, a is equal to y of 0, y naught minus 3. So therefore, yt is equal to y naught minus 3 into minus 4 divided by 3 raised to power t plus what we get over here is plus 3. Now this is the definite solution. Clear? Now yt is equal to y naught minus 3 into minus 4 by 3 into t plus 3. Again, we very well know that this y naught minus 3 is the a part of the solution. This minus 4 by 3 is the b part of the solution, and this is t. So what we do next is that we will change the terms from y to p. Therefore, pt is equal to now p naught minus 3 multiply by minus 4 by 3, the whole raised to power t plus 3. Over here, what we can do is that we can assume that as according to the derivation, this 3 is the value of equilibrium prices. That is, this 3 is referred to as equilibrium prices. So therefore, pt is equal to p naught minus p bar into minus 4 by 3 raised to power t plus 3. This is the solution for this particular question. Again, this p naught minus 3 is the a part of the solution. This is b part of the solution. T is at its own place, where, t is the, okay, this is the t value, clear, and this 3 is again the p bar. So therefore, p bar comes into the a term, and p bar comes over here also as the an addition to this a b raised to power t. So this is the solution for this particular question. I would request you, I'm giving you an homework, and I believe that you people will solve that question and show it to me. And the homework over here is now homework question is Q dt is equal to 22 minus 3 pt. And for anyone else who also is finding my videos helpful, they can also solve this question in order to get the best idea of how much have they understood the topic. 22 minus 3 pt, okay? Now qst is equal to minus 2 plus pt minus 1. Due to some irrelevant comments by some random people on the posts, I generally have switch off the comments for my posts, but if there are any questions, you can request me and I will explain them to you. Thank you very much. This lecture has been completed over here. If there is any question, anyone can ask me through the comments in any of the videos, and you can comment for the given video on any other video. The videos on which the comments were irrelevant or extremely out of context, I have stopped post the comment section for those videos, but you can ask me a relevant question on any other video regarding to any other video, and I will answer them to you. Thank you very much. Thank you.